Chris, and in this lesson we're going to take a look at how to draw Lewis dot structures in chemistry. And basically when we say dot, all that means in these Lewis structures is the dots represent the electrons that are being shared between atoms that are bound together. So we're going to look at two examples here of how this works for H2O, which is water, and how this works for carbon dioxide so that we can see our Lewis dot structures. So first, let's take a look at H2O. Now, in order to draw a Lewis dot structure, we have to be able to identify the number of valence electrons that each element contains. And that comes from looking at your periodic table. So on your periodic table, we're going to draw a little one over here. Our periodic table looks something like this, and the way that we count valence electrons for any element, it's in that first column, it has one valence electron, then two. And as far as valence electrons are concerned, we actually skip over all of these in here, these transition metals we're going to skip over in terms of counting the valence electrons. So it's just one valence electron for that first column, two for the second column, and then over here we have 3, 4, 5, 6, 7, and the last column, all of your noble gases have 8 valence electrons. So 1 through 8 for each of those columns across your periodic table will tell you how many valence electrons correspond to certain elements. And in this case with H2O, hydrogen, if we look for H, it's in that first column, and oxygen is in our 6th column. So we have a valence of 1 for each of the hydrogens and a valence of 6 for each of those oxygens. So we can just write that down for now so that we know how to keep track of those dots or those electrons in the sharing of electrons in these bonds. So since hydrogen has only one electron, that means that when hydrogen forms a bond, it wants to form a bond where it can share one more electron so that it'll have a total of 2. And for that very first energy level, 2 electrons would be a complete energy level. So with water, oxygen is going to be bound to hydrogen, and it's going to share one of its electrons. So oxygen has 6 around it, and hydrogen over here has 1 around it. And in any bond between two elements, each bond that you see, which oftentimes is written out as a line, but for Lewis dot structures we're going to include the dots, each bond that you see contains 2 electrons. So we see that oxygen is bound to hydrogen this way, and oxygen is bound to this other hydrogen this way. So in H2O, we have 2 bonds being formed between hydrogen and oxygen, and each of those bonds shares 2 electrons. And then if we count the total electrons around our central atom, the oxygen here, it's 1, 2, 3, 4, 5, 6, 7, 8, which means that it fulfills octet rule, that it has 8 electrons surrounding it for a complete electron energy level there, and then 2 surrounding each hydrogen for a complete energy level there. Because hydrogen, one of the few exceptions, it only has a max of 2 electrons that it can be involved in sharing, since it only has that very first energy level. Let's take a look at one more example for carbon dioxide, and we're going to see the same thing applied, except here both carbon and oxygen have the potential of fulfilling octet rule and having 8 electrons around them. So let's see how they can share appropriately so that we make sure that both the carbon and the oxygens in this molecule will have 8 electrons and fulfill octet rule. So the carbon's listed first, which means that that's going to be the one in the center, and the oxygens are going to be attached to it in some way. And then if we take a look at our periodic table to figure out the number of valence electrons, so let's see where carbon falls in which column of the periodic table. And if we look carefully, we see that carbon's over here with a valence of 4. So we have 4 valence electrons for the carbon and 6 for each of those oxygens. So let's go ahead and start drawing out our electrons. Oxygen has 1, 2, 3, 4, 5, 6. Carbon has 1, 2, 3, 4. This oxygen has 1, 2, 3, 4, 5, 6. And what's going to happen here, carbon right now has 4 electrons around it, which means that in order to get to 8, carbon wants to be involved with the sharing of 4 more electrons. So that means that we're actually going to have a bond formed here, 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 and here. So that now carbon has access to all 8 of those electrons. And if we look at each oxygen, by sharing with 2 of the electrons from carbon, the valence of 6, adding those 2 more, now oxygen fulfills octet rule because it has access to those 8 electrons. And basically that's the idea with Lewis dot structures, is in order to figure out the bonding, you're just looking at the number of electrons that each element needs in order to complete its valence shell of electrons and achieve that ideal number of 8, and in some cases, as is the case with hydrogen, an ideal number of 2 when you're talking about only that first energy level. So if you have further questions, please feel free to watch more of our videos. You can visit our website at sandersontestprep.com and check out more chemistry lessons on STP TV. Thanks for watching.